Networking. In this video I'm going to explain every major networking concept, from the cable that connects your computer all the way up to VPNs, TLS, and load balancers. Okay, so let's start from scratch. We have a single computer. If we want this device to talk to anything, we need to at least connect a cable. Ethernet is the standard for wired connections. Physical cables like copper or fiber optic. Wi-Fi, it does the same thing by sending data through the air. Same concept, but different medium to carry the data. Let's pick a cable for now. So now that we have our cable, let's connect a second device. Even though they are already connected, there is a problem here. Neither of them knows who is on the other side. MAC address. Every network device is born with a unique hardware identifier. It looks something like this, and it's meant to be unique for each device. When two devices are directly connected, they use MAC addresses to recognize each other. And that's pretty cool. But what happens if you need to connect 10 devices or 100? Switch. A switch connects multiple devices on the same network. It reads the destination MAC address on each request and sends it only to the right device. However, there is a limitation. MAC addresses only work locally. You cannot use it to reach a device on a different network. That means that we need a different type of address, IP address, a logical address assigned to your device, so it can be identified across networks. They look like this. These ones are different. They can change. To get an IP address, you have two options. One, you can assign it manually to your device. You go into your network settings and type in yourself. That's cool. And static IP address. Or two, you can use DHCP, Dynamic Host Configuration Protocol. When your device joins a network, DHCP assigns an IP automatically, avoiding the manual setup. Now that our device has an IP address, it can communicate with hundreds, even thousands of devices across different networks. And networks can be really big, but also really small. Subnet. A subnet defines the size of your local network. It tells your device how big or small the network is. So now our device is ready to explore the outside world. But how can it do it? Router. A router connects different networks together. It looks at the destination IP and decides where to forward the data next. It is the exit door of your local network. But a network can have multiple routers connected to it, so your device needs to know which one to use. That's our default gateway. It's basically our device saying, I have no idea where this packet needs to go. I will just send it to my default gateway and let it figure it out. But now that the router has that packet, how does it know where to send it? Routes. A route is a rule that tells the router where to forward traffic based on the destination. You can set this manually. That's called static routing. You tell the router to reach in this network, use this path. For two small networks, static routing works fine. But imagine dozens of networks inside a company. That gets complex. OSPF. It is a routing protocol that allows routers inside the same organization to talk to each other, to find the best paths automatically. But what about the internet? Millions of networks run by different companies. BGP, Border Gateway Protocol. BGP is the routing protocol that large companies like internet service providers use to exchange routing information with each other. It's basically the protocol that makes the internet. So, static routing for small setups, OSPF for larger internal networks in a single company, and BGP for companies to companies. This is basically how the internet is made. A lot of companies talking to a lot of companies. Now we have a full network, devices connected locally, routers forwarding traffic, and routing protocols making sure everything is reachable. Let's test it. We can send a simple ping. Ping sends a small packet to a destination and waits for a response. If the other side replies, you know it's alive. Ping uses ICMP. It is a protocol used for network troubleshooting. It succeeded. Our data can reach the other side. But there are different ways to send data, different protocols for different needs. TCP. It creates a connection between two devices before sending any data. It's to make sure every packet arrives without errors. If a packet gets lost, TCP sends it again. TCP is safe, very slow, because it needs to wait for the confirmation that every packet was delivered. That's why it's used for things like file transfers. UDP. This one is different. If a packet gets lost, it's gone forever, but it's faster because we don't need to wait for confirmations. That's why it's used for things like video calls, gaming, and live streaming. A few packets lost won't break anything. So TCP when you need reliability, UDP when you need speed. But I have a question. Your PC can transfer files and make video calls at the same time, right? How does it use both protocols at the same time? The answer, ports. A port is a number that tells the device which application should handle the data. IP gets you to the right device, the port gets you to the right application. For example, port 443 for web traffic, and this one for your video call. So our device sends a packet to port 443 on a remote server. But it's not working, like if something is blocking it. A firewall controls what traffic is allowed in and out of a network. It can block specific ports, IP addresses, or types of traffic. We need to add a firewall rule so that our packet can finally reach the server. Now we are communicating. Wait, who is this guy? It is a hacker sitting between us and the server, and he can read everything we are sending. Password, messages, all of it. That's because our data is being sent in plain text. TLS. Transport Layer Security. It encrypts the connection between two devices so no one in the middle can read or change the data. You have also probably heard about SSL before. TLS is basically the modern version of it. Same idea, newer version. So TLS protects one connection, like our browser talking to that server. But what if you want to protect everything, every connection from our network to this other one, VPN, Virtual Private Network? It creates an encrypted tunnel between your device or network and another one. The traffic you send through the tunnel, it's protected, so no one in the middle can see what you are sending or receiving. So far, we have been using IP addresses to reach other devices, but when you open your browser, you don't type an IP address to visit a website. You type a name, something like google.com DNS, Domain Name System. It translates domain names into IP addresses, so you don't have to memorize something like this. Okay, so now we have TCP to send the data, TLS to encrypt the data. Now we are just missing the data, HTTP. It's the way our browser uses to request and receive web traffic, like web pages, for example. Give me this page. Here it is. And if you combine HTTP with TLS, you get HTTPS. Now our device can finally use that server. This other device too, this one as well, and this one, and this other one, and thousands of them. That server is not going to keep up. Load balancer. A load balancer sits in front of multiple servers and distributes requests across them. This prevents overload and keeps the service running. We started with a single device in a cable, and we ended up balancing traffic across the internet. That's networking. Every concept builds on top of another one. Every concept has its own role. A good rule for learning something is to always ask yourself, why do I need this? And what problem does it solve? If this video helped you to understand networking better, give me some feedback in the comments. I will appreciate it. Thanks for watching and see you in the next one.